All right, yesterday we discussed some graphing of rational functions and as it related to vertical and horizontal asymptotes. Today we're going to talk about, rather than horizontal asymptotes, these things called slanted asymptotes, which are basically, rather than vertical lines, they're slanted lines that describe end behavior. And we're going to talk about something called holes, or not. They're basically places in the graph in which the graph is not defined, however, it doesn't create an asymptote because it's not in the denominator of the fraction. So today, when determining our asymptotes of the horizontal nature, if you have a situation where the degree of the numerator is one more than the degree of the denominator, there are no horizontal asymptotes, but a slant asymptote is created, and you have to use long division to find out what that is. So let's take a look at a few examples. So in this case, here's a situation where the degree of the numerator is one more than the degree of the denominator. And since this is in an x minus c form, I can go ahead and use synthetic division, which I think I'll do. This gets me a 1 here, 0 here, and 3 here. Bring the 1 down, multiply, get a 2, add 2, multiply, and get a 4 here, add 7. This actually doesn't matter though, we're just using our c term and our x term, so this is x plus 2 is our slant asymptote. To find our x-intercept, we set y equal to 0, or in other words, when we set y equal to 0, basically it's like setting the numerator equal to 0. We note that we have -3 is equal to x squared. That's never going to happen, so there are no asymptotes there, or there are no x-intercepts. When I want to find my y-intercept, I set x equal to 0. And in that case, I get -3 halves. And then we'll have a vertical asymptote, what sets the denominator equal to 0, and that's when x equals 2. Again, we're going to take and set up our axes. We're going to take and draw in our asymptotes. We have a vertical asymptote of 2. Let's call that right here. And then we have a slant of let's start at 2, let's say, go this way, and clean that up a little bit by extending it. Let's try it again. Extend that, something like this. Put some labels in. This is 2. That would be -2 since the slope is 1. We know this is 2. And we have no x-intercepts. And we do have, what do we have? We have a y-intercept of -3 halves. So, like this. If I have no x-intercepts, it can never cross the axis. So I really don't need to pick any points to finish this graph. I can go through this point and down, because if I went up, it would cross. And I can go through this point and approach that slant asymptote. Again, the slant asymptote, just like the horizontal asymptote, describes end behavior. Can't draw the graph over here. It's got to be up here in this little corner, because it can't cross that x-axis. So again, we have a situation where we have degree of the numerator one more than the degree of the denominator, so it looks like we're going to have a slant asymptote. However, if we take a look at this thing, we'll see that this can be factored. I don't know if that will change anything. Doesn't appear so. It just makes it easier to find our x-intercepts. So let's do that first. Set that equal to 0. Therefore, x equals -2 and -3 for my x-intercepts. Y-intercept will be 6/5. Vertical asymptotes, it's going to be x equals -5. We'll go synthetic division again. Put a -5 here. 1, 5, 6. Bring the 1 down, multiply, -5, 0. And again, the remainder doesn't matter. We're just looking for the c and the x value for an equation of a line. So y equals x is our slant. Set up our axis. Draw in our asymptotes. Vertical of -5, let's call that roughly here. Y equals x. Something like this. Extend that a little bit. See if I can do that, like so. And put in our let's see, got all my asymptotes, -2 and -3. This was -5. This is 0. -2, call it here. -3, call it here. Put dots on both of those. And I know that the y-intercept is 6/5, somewhere around here. So again, it looks like I can draw my graph pretty simply. We're going to go here. My multiplicity is 1 in each case of my root, so it has to go through and go through. It goes up. There's no more x-intercepts over here, so this part of my graph looks like such. All right, now in this case, you'll notice it's set up such that I have equal factors of x minus 1 in the problem. Now, when you have a reduction of equal factors, it creates what's called a hole. Prior to walking into this problem, you would have thought I have a vertical asymptote at 1, but since it's going to reduce out, I don't. However, it does have something to do with the problem. A hole's created, so at +1, something's going to happen. Basically, there's going to be an empty place in the graph, and then it's just going to continue on after that. It's not going to affect asymptotically the function. So what I need to do to find the y value is I take what's left and find the value when I plug 1 in. So you'll see that's 3. 1 minus 2 quantity squared over 1 minus 4. This is basically a 1 times 3 is 3 over -3, which is -1. So I have a hole at 1 and -1. Got to have both the x and the y value. Then I can take and use what's left in the function, which is the x minus 2 squared over x minus 4, and find basically everything I need. I've got my x-intercept of 0 equaling 3 times x minus 2 quantity squared. I have x equals 2. And notice multiplicity of 2. So since that's even, that's going to bounce off an axis. We know that. We've got a y-intercept setting x equal to 0. I have -2 squared is 4. That's 12 over -4, which is -3, equals y. And I have a vertical asymptote of 4. And you'll notice in this case again, I actually have 3x squared, that's 4, that's -12x, and that's +4 plus 12 over x minus 4. So again, I'm going to have another slant, no horizontal. So since I know my C term is 4. I'll put my 3 here, my negative 12 here, my 12 here. Bring the 3 down. Multiply, get 12, get 0 again. Again, this term doesn't matter, so y equals 3x is going to be my slant. So let's go ahead and graph this now. I know, first of all, that I'm going to take and have a vertical asymptote, and we said that was going to be at 4. So we'll drop that in. Slope of y equals 3x for my slant. X is a 45, 3x is going to be pretty steep. So we'll do something like this and extend those guys as well. Let's do that. This one up a little more. We'll do it like that, I guess. And this guy will bring down a little more. Like so. I have some points I need to graph. We had a x-intercept of 2 right here. Did we have a y-intercept? Y-intercept of negative 3 right here. All right, so I know what this looks like as well. I know that at this root, I'm going to bounce off the axis because I have an even multiplicity. So this is going to come down here. I'm going to come up here and I'm going to bounce off and go down. There's no x-intercepts over here, so I know this has got to go up. And then I know that I'm going to have a hole at -1 or 1, -1. So right around here, I'm going to take that piece out. And I'm going to draw an open circle saying at 1, -1, there's a hole. And here's another situation. Notice I've put these hole examples already pre-factored. That's not always going to be the case. You might have to factor polynomials first to see that you're going to have like factors. So again, these two reduce out, and you know you have a hole at -2 and whatever f of -2 is. So let's do that real quick. That will be 3 and -6 over 5 and -3. The 3's reduce. Negative over negative is a positive. So I end up with 6/5 as my hole. My x-intercept, set the numerator equal to 0. And remember, it's the remaining numerator. So I have 4 and -5. Y-intercept, use the remaining polynomial to find that. So it looks like I have -20 over 7 for that. Vertical asymptote looks to be -7 and 1 for x. And horizontal in this case, it will have a horizontal because notice if I were to multiply these out, I would have x squared on top and x squared on bottom. So if I take the leading coefficient, which is 1 on the top and 1 on the bottom, then I have a horizontal of y equals 1. The same process, create our graph, start drawing in some asymptotes. We've got this vertical at -7. Let's put it way over here. And at 1, got our horizontal at 1 as well. And now we'll start drawing in points that we have. I've got a x-intercept at 4, well, at 4, and a -5. Dot there, dot there. Y-intercept at -20 over 7, so that's about -3. Almost. And then what else do I know? I think that's about it. Okay, so now I can say, what can I say? I can graph this thing without doing or plugging in any points. So I know for a fact that my degrees or multiplicities of my roots are 1, so I know it passes through this point and approaches these. I know it can't cross the x-axis here, so this has got to go down. And then this point has to come into here. And because I have a multiplicity of 1, it has to go through that point, cross the horizontal. Remember, it can do that because horizontals only describe end behavior. And then since over here I have no x-intercept, it can't go down here, it has to go up here. And then finally what we have to do is we have to go back in and throw our hole in. So at -2, let's call it -6/5. Oh, it's not super accurate, but we'll be close. Right around here, we'll take and have our hole.